On this Ram 1500 Classic with the 3.6 Pentastar, P0440 is a general EVAP system failure. In plain terms, the PCM is trying to confirm that the evaporative emission system can pull the expected vacuum response and see the ESIM switch react. The driver may only notice the MIL, and the truck may otherwise run normally. Broadly, this can involve a possible EVAP leak purge control issue, ESIM switch or circuit issue, vent restriction, or sensor feedback that does not line up with system behavior. The key is not to guess at parts. Work the system response in order. Before judging the result, make sure the monitor had a fair chance to run. Some EVAP monitor logic uses an engine on/drive cycle for a minimum of 2-5 minutes, and the engine on timer is clipped to a maximum of 26 minutes on any given trip. There is also a 12-minute delay time where the PCM ignores ESIM switch input. If the event goes a maximum time of 17.5 hours without an ESIM switch closure, the monitor logic keeps tracking that failure. The accumulation fail timers are calibrated at engine on 100 minutes and engine off 70 hours. For the cold start gate on this P0440 path, the ECT and AAT inputs need to be less than 10 degrees C, 19 degrees F. Apart, fuel level needs to be between 12% and 88%, and ambient temperature needs to be between 4 degrees C and 35 degrees C, 40 degrees F, and 95 degrees F. For P0440, the PCM is looking for the EVAP system to create vacuum during purge and for the ESIM switch to respond. If the switch does not close during purging, or vacuum cannot be created below -250 Pa within the calibrated time, that is treated as a general EVAP system failure. The ESIM relief valves regulate system pressure between approximately 1 H2O and -2 H2O, or 250 Pa and -500 Pa. When system vacuum reaches between -187 Pa and -250 Pa, it acts on the diaphragm and closes the vacuum switch. The ESIM signal will typically be a 12-0 or 5-0 signal depending on the vehicle, and the voltage signals can vary between vehicles and may be somewhere between 5-0 and 12-0 volts. The fuel tank pressure sensor is not what the PCM uses to decide the leak result, but it is very useful for watching what the system is doing during diagnosis. Before getting into the EVAP testing, start with the basic system checks. Look for any applicable service bulletins or PCM flash updates that relate to this fault. If there is one, handle that first, then test the system and verify it is operating properly before continuing. Now perform the EVAP system leak evaluation with the scan data on screen. Watch and document purge duty cycle %, ESIM switch state, and fuel tank pressure, Pa. For best results, the fuel tank should be less than 95% of fuel tank capacity. Also remember, these readings are not absolute. Tank size, fuel volume, barometric pressure, ambient temperature, fuel temperature, and temperature change can all move the results around. Extreme temperature swings can either hide a leak or make a sealed system look like it is leaking. First, with the ignition on, vent the EVAP system to atmosphere and watch the ESIM switch and fuel tank pressure sensor. You can vent it by removing the gas cap, opening the capless filler, or actuating the purge solenoid for 1 minute with the scan tool. At this point, the ESIM switch should be open, and the fuel tank pressure reading should be near 0. Do not get hung up on the pressure value being exactly 0. Whatever the sensor reads while the system is vented becomes your 0 reference. If the ESIM switch reads closed here, think short to ground on the ESIM signal, a switch stuck closed, or the purge solenoid not opening if you used it to vent the system. Next, close the system and monitor it with the ignition on and the engine off for 2-3 minutes. Document the fuel tank pressure reading. A good sealed system should usually start to drift slowly into pressure or vacuum, depending on whether the system is heating or cooling. If the pressure changes more than 200 Pa in 1 minute, the system is too unstable to test accurately. If the value stays steady, it may be leaking. or the temperature may simply be too stable to create a pressure change. If the pressure changes very rapidly, the temperature change is too large, and the result is not dependable. Now start the engine and capture the ESIM switch state and fuel tank pressure within 5-10 seconds, while the purge solenoid is still off. You should only see a small vacuum from fuel being pulled from the tank, typically between approximately -25 and -50 Pa. If vacuum shows up instantly near or below the ESIM regulation point, -500 Pa, that points toward a purge solenoid that is leaking. Next, get purge active long enough to create maximum vacuum and let it stabilize. Then shut the engine off right after maximum vacuum is reached. The recommended way is to turn the engine off after the previous capture, run the purge vapors system test, follow the on-screen prompts, and once purge is activated and vacuum is created, turn the engine off and return to the data display. Do this as quickly as practical, because too much heat in the fuel and tank can make the vacuum decay too fast in the next phase and lead you the wrong way. In this phase, the system should reach approximately -600 Pa. Fuel tank pressure should drop quickly to approximately -600 Pa, and the ESIM switch should change to closed. If fuel tank pressure drops the way it should but the ESIM switch does not close, look at a switch stuck open, or an open in the ESIM signal or ground circuit. If the ESIM switch closes but fuel tank pressure changes very little or not at all, think about a restriction between the canister and the fuel tank pressure sensor, or a sensor problem. Verify the 5-volt supply is present before condemning the sensor. If the switch does not close and pressure barely changes, think very large leak or a purge solenoid that is not opening when actuated. And if the vacuum created is 2 to 3 times the expected reading, look for a plugged canister vent hose, plugged fresh air filter, or an ESIM vacuum vent valve stuck closed. Once maximum vacuum has been created and stabilized, shut the engine off and monitor the fuel tank pressure sensor and ESIM switch for another 3-4 minutes. Record the readings immediately after shutdown and again after 3-4 minutes. The fuel tank pressure sensor should quickly return to the vacuum relief regulation point, approximately -500 Pa, and stabilize. Vacuum should stay below approximately -250 Pa, and the ESIM switch should remain closed for the additional 3-4 minutes. If fuel tank pressure rises quickly near zero or above -250 Pa, and the ESIM switch opens within the 3-4 minutes, treat that as a leak and move into leak location testing. If every phase matches the expected behavior, the system is most likely not leaking at that time. In that case, possible false failure causes include software issues, debris that was temporarily stuck in the purge solenoid or one of the ESIM relief valves and has cleared, or the ESIM not mounted correctly with the switch at the 3 o'clock position. If the decay check points to a leak, choose how you want to locate it. You can test the whole EVAP system as one assembly, or you can split the system at the charcoal canister and isolate the fuel tank side from the fresh air and canister side. Either approach is valid. The important part is to follow the result instead of jumping ahead. For a whole system test, use the yield and the proper adapter. Connect the red lead to battery positive and the black lead to battery negative. Connect shop air. Set the tester to AIR. And calibrate the flow meter by blocking the tester air supply tip while pressing the remote start button. If the indicator ball is not on the bottom of the air flow meter, set the red flag to the ball. Then connect adapter 8440 to the ESIM vent hose. Connect the clear air supply hose and activate airflow. Compare the ball to the red flag. If the tester is calibrated correctly, the ball should rest on the bottom of the airflow meter when there is no leak. Depending on fuel level and venting configuration, it can take several minutes to fill the system. If the ball drops to the bottom of the airflow meter, or below the red flag, the rest of the system is sealed and the leak is coming from the vent valves inside the ESIM. Replace the ESIM, then run the intrusive leak evaluation again to verify the repair. If the ball stays above the red flag, the leak is somewhere else in the EVAP system. Locate and repair it with smoke, a hydrocarbon sniffer, or a bubble test. To check the purge solenoid for an internal leak, remove the manifold hose from the purge solenoid, fill the system with smoke, and watch for smoke coming through the purge solenoid. If smoke is present, replace the purge solenoid, then run the intrusive leak evaluation again to verify the repair. If you choose to split the system, remove the canister tube from the charcoal canister. This is the tube that connects to the fuel tank on the other end. Attach a hand vacuum pump to the canister fitting and pump it until the ESIM switch closes. Then monitor ESIM switch state with the scan tool for up to 10 minutes. With the fuel tank vapor pressure removed from that side of the system, the switch should stay closed, assuming there is no or minimal temperature change. If the ESIM switch stays closed for a minimum of 5 minutes, the leak is on the fuel tank side. If it does not, the leak is on the fresh air and canister side. For the fuel tank side, use the yield with smoke. Connect the red lead to battery positive, the black lead to battery negative, connect shop air, set the tester to smoke, attach the black hose to the canister tube, and press the remote button to fill the fuel tank side with smoke. Then find the leak using smoke around connections and sealing points. A TIF 8800X combustible gas detector or equivalent, or a bubble test using MOPR air leak detector or equivalent. Repair or replace the leaking component. If checking the purge solenoid internally, remove the manifold hose, fill the system with smoke, and if smoke comes through the purge solenoid, replace the purge solenoid. After the repair, run the intrusive leak evaluation again to verify it. For the fresh air and canister side, use the yield in AIR mode and calibrate the flow meter the same way. Power and ground connected, shop air connected. Block the clear air supply tip while pressing the remote button, and set the red flag to the indicator ball if the ball is not at the bottom. Connect adapter 1500P to the ESIM vent hose, connect the clear hose, and activate airflow. If the ball drops to the bottom of the airflow meter, or below the red flag, the leak is coming from the vent valves inside the ESIM, so replace the ESIM. If the ball stays above the red flag, leak test the system with smoke, hydrocarbon detection, or bubbles, and repair the leak you find. Check the purge solenoid for an internal leak the same way as before, and replace it if smoke comes through. Then run the intrusive leak evaluation again to verify the repair. Keep verification separate from fault finding. Once the leak or response problem is repaired, repeat the intrusive leak evaluation and confirm the ESIM switch and fuel tank pressure behavior stay in range through the test. The takeaway on P0440 is simple. Prove whether the system can create vacuum. Prove the ESIM switch responds. Then isolate the leak path only after the data says a leak is present. For more diagnostic training, visit stepdiagnostics.com.